This is the first section of the first lecture. We will be talking about social psychology as an empirical science. One of the fundamental principles in social psychology for researchers, or one in general, is that many, if not most, social problems can be studied scientifically. It is of course possible that studying certain problems is unethical, but we will talk about that in a later section of this chapter. Also, it is important to note that simple conjecture and untested hypotheses are not sufficient. We will also talk about hypotheses in a couple slides. This just means that coming up with one's own personal theory about why something is the way it is, which unfortunately is very common when it comes to most of the topics we will talk about in social psychology, are not sufficient to make any serious claims or to build theories upon. A lot of what we will cover in this course is going to seem obvious, and it will be very familiar because many of the topics that we will cover are things that pertain to our daily and social lives. Not to mention, people over many thousands of years have been trying to come up with explanations for many of these behaviors. That being said, occasionally there are common situations that will defy our expectations. To get a good idea of this, I highly recommend trying the quiz on page 25 of your textbook. It is also important to remember that many results around studies dealing with human behavior are going to seem predictable in hindsight. This is true in other domains as well, and it is less the case in specific ones. For example, in theoretical physics, you're probably not going to come to the conclusion that you knew that all along. Whereas a lot of psychological studies will present data that sort of leads us to support a sort of half-baked theory we had before going into it. There is this very common saying, hindsight is 20/20, and it ultimately is just referring to the idea that as we look back, of course we know because we have been through it. So much so that this is actually a phenomenon that has been studied, and it is referred to as hindsight bias. Hindsight bias refers to the tendency for people to exaggerate after knowing that something has occurred, how much they could have predicted it before it occurred. Here's just a fake example, and just imagine for a second you go in for a certain medical procedure and the doctor tells you there is a 50% chance of success and a 50% chance of failure. Upon the procedure failing, many of us will have the following internal statement: I shouldn't have done it. I knew it wouldn't work. Now, this is a very common sentiment. It's one of the ways that we explain the world to ourselves and manage our own emotional states. But the truth is, we didn't know it wouldn't work. If we knew it wouldn't have worked, we would not have embarked on the procedure. The opposite can also be true. There would be many who will not take part in this because they're convinced of it failing beforehand, but the truth is, there is no way to know. And after the fact, we will oftentimes change our own mental representations of how we remember a fact to make it fit with our current theories. If this is something you would like to look into more, there is a lot of literature on this in cognitive psychology and how our memories are quite biased. Moving on to hypotheses and theories. So a hypothesis is basically the core of all science, and it refers to a prediction in regard to some specific outcome that a researcher expects to observe in a study. One of the most important things about a hypothesis is that it must be falsifiable. This means you must be able to prove that it is false. For example, I might come to the conclusion and thus hypothesize that if people were smacked in the face repeatedly, their levels of anger and frustration will rise. Now, while this might make sense to a lot of people, it is also falsifiable. I could show that by smacking and hitting people over and over, their anger levels actually don't change, or even more astonishing, their anger levels would go down. However unlikely that is to take place, it is nonetheless possible in the world we live in for those opposing predictions to come true or to manifest themselves. Thus, the original hypothesis of people getting smacked will generally be angrier is falsifiable. A statement that is not falsifiable does not count as a hypothesis. It cannot be tested using the scientific method. A theory is a set of statements that describe general principles about how variables relate to one another. It is often a more overarching theory as opposed to a specific set of prediction relating to a single context or circumstance. A theory must also be falsifiable. Now, there are grades to this. Oftentimes, certain aspects of a theory can be falsified, causing it to then be updated, or occasionally an entire theory itself will be supplanted by, another theory that explains the data in a better way. There's an old quote by Feynman, who was an award-winning physicist, who said to the effect that the scientific method is the grand equalizer, because you come up with a hypothesis and you go out and you measure the world. And if your measurements don't agree with your hypothesis, you are wrong, regardless of who you are. And in a way, this is the basis of all science. When it comes to creating hypotheses, while they are occasionally eureka moments, they are relatively few and far between. Just in case, eureka is a reference to something spontaneously coming to one or popping in one's mind. The cartoon analogy would be the light bulb above your head all of a sudden turning on and you just have the answer. It refers to an ancient Greek who apparently was taking a bath and watched water spill over the bathtub and realized that volume was conserved. Other hypotheses are derived from everyday experiences. These could be things a researcher, like yourself, for example, sees in the world, or hears about during conversations with somebody else, or simply watches other people's behaviors. Other hypotheses are derived from dissatisfaction with existing theories or explanations. You could be reading a theory in this textbook, for example, and say to yourself, yes, well, overall it makes sense, but I think a different way of approaching this would explain the data better. You could then generate your own hypotheses, go out and test them, and give that theory a run for its money. Primarily, though, hypotheses are generated through something called theory refinement. Theory refinement refers to the process by which specific hypotheses are developed based on some existing theory. So if a theory, for example, talked about a certain class of people operating in a certain way, you could update this by looking at different populations of people to see if this theory holds true. The theory is then continually updated to account for the findings based on testing these previously developed hypotheses. And then once that theory is updated to take into account this new data, maybe it doesn't change very much at all, or it's changed quite drastically. Regardless, using then this updated theory, new hypotheses are generated. And then this process repeats itself. And ideally, it iterates over and over, and this is ultimately the process of how scientific disciplines approach the truth. A note about science in general and falsifiability. So, as mentioned previously, in science as a whole, across all disciplines within it, idle speculation is insufficient. One must collect data in some form or another and test hypotheses. There are arguments to be made for their different forms of testing sort of observed data using different methodologies that are not through null hypothesis testing, but ultimately they're almost always going to be some form of a hypothesis and some test involved. If this is not the case, no conclusions can be made. Further, as mentioned previously, all scientific statements must be falsifiable, else they are not scientific statements. This means that each one must contain the possibility of being disproved, again as mentioned earlier, but I cannot overstate this. It is simply one of the most fundamental qualities of any scientific endeavor, and it is unfortunately often overlooked by the common misconception that science is about proving the truth. Ultimately, science as a methodology, the scientific method, is all about falsification. It is not actually in the business of proving truth. This is due to a couple of reasons. One is due to the use of statistics as the basis of hypothesis testing, and also the inherent uncertainty in the natural world. Now, just imagine trying to compare two different groups of people. Those groups of people, even though at an aggregate level might be different from each other, every single individual within them is also different. How can you ever truly know that the differences between those groups are not a unique product of the individuals within them? This is ultimately why a learning of statistics is so important. But there is another fundamental problem with trying to prove truth. And if you'd like to read more on this, Sir Karl Popper, I believe, is the one who originated this idea. The concept is there are an infinite set of variations in which you would need to test the context of an experiment in order to show that it held true completely, because true is that it is always the case. It cannot be true sometimes. That doesn't really make it true. Yet all you need to do to falsify something is show that it is false in one context. Because it is practically impossible for human beings to run every possible iteration of an experiment, we basically cannot prove anything true. That is beyond the purview of our understanding. Thus, even though it is a common misconception that science is all about truth, it is actually about falsification and certain things standing the test of time. By this I mean that they have not been falsified over repeated attempts to do so. It is also worth noting that this is one thing that is oftentimes used to critique scientists when they are talking about manners of change that are required that we oftentimes don't want to. You hear this a lot in climate change policies and arguments. Many people who are deniers of human-centric climate change will say something to the effect of, well, yes, you have shown us all this evidence, but you cannot prove unequivocally so that it is the result of human beings who are driving this climate change. And a scientist in return would say something to the effect of, yes, while we are 96% certain that this is the product of human current society, we cannot say with 100% certainty, with truth, that it is human beings driving this climate change. Now, you can decide for yourself if a 96% certainty metric is enough to convince you, but remember, no matter how much you believe something to be the case, when it comes to science, there is no such thing as a true truth. We just try and get as close as we can. And this is the never-ending pursuit of discovering knowledge with science.